So hi gang, I made a promise a while back to kind of go through the circuitry on a Binson since I've decided to stop doing repairs. Thought I'd go through and try to transfer some of the knowledge I've gained over the years to you all. So thought I'd kind of go through the basic circuitry of a Binson, and there's nothing simpler than a Echorec Baby. This is also very similar to the circuit in the B1. The difference generally being multiple inputs. There's a number of different variations to the input and outputs on this, but it's generally the same circuit. So I'm going to start down here at the power supply. All Binsons generally have this type of transformer in them. The primary is configured as what we would call an auto transformer. Imagine it as a variac with different taps on it. So basically you can tap in at these voltages, 100, 125, 145, 160, 220, 270 volts. And the magic of this transformer is whichever of these windings you excite with the appropriate voltage, these voltages appear at these terminals. So if you, if you go with 125 volts or 110, it will make the 220 volts, which then goes off to the motor. So then this drives a grounded center tap secondary for the filaments, 6.3 volts, and then a single winding 250 volt secondary for the high voltage. That generally feeds a bridge rectifier assembly. It's a little silver box that you'll see heat sunk to the chassis. This contains selenium rectifiers, which freak some people out. Personally, I just leave them in there. There's nothing too dangerous in there. I've never seen one really fail, but they have on occasion, and then you'll see a lot of times someone will put a assembly of 4 diodes in a bridge rectifier configuration to replace that. So that tap will go to the first stage of the DC output filter, 32 mic at 350. This is generally one of those stud-mounted can electrolytic capacitors, 3.9 kilo ohms between the two capacitors to create a 240 volt tap and a 220 volt tap from this 4.7K resistor. I'm sorry, 47K, excuse me. So there's an 8 microfarad capacitor here, which makes the lower voltage DC at 220, which you see in this schematic. This is an Italian schematic. So here's your input, or excuse me, your voltage taps here, voltage tap 1, voltage tap 2, voltage tap 2 down here. So we'll now move over to the input. Now this is annotated with troubleshooting guide here. So basically for a 1 millivolt input at 1 kilohertz, you should see throughout this circuit these voltage levels. I've never personally verified that, but it kind of gives you an idea of the gains and where you should be with voltage levels in the circuit. All right. The capacitances are in picofarads. So 47,000 picofarads here will be 0.047 microfarads. The larger capacitors are generally mustard capacitors. These smaller ones, this, like for example, this 820K, this 820 picofarad, 220 picofarad, these will generally be ceramics. Now there is universally on Echorecs, off of any input, there is a 47 kilo ohm resistor. These rectangular boxes with a value in them. These are resistors on these schematics. So you've got a 47 kilo ohm input impedance on just about every Echorec out there. There's a 1 mega ohm resistor to ground here from the grid of the first triode, ECC 83 or 12AX7, and it's coupled through a 0.047 microfarad capacitor. This triode is operated in grounded cathode configuration and provides about a gain of 50, more or less, to your input signal. There's a 100 kilo ohm plate resistor, 220 volt input. Generally speaking, there's about a milliamp through here. So you're generally running here at about between 110 or so volts DC. On your Echorec 2 schematics and so forth, that will be noted directly and generally speaking, I found those to be very accurate. So we come off of here through a 0.047 microfarad capacitor, and the signal's split in two directions. First off is it drives, puts the output across this 1 mega ohm pot. This will be a trim pot in the back of the unit, and this is your wet-dry mix. So this allows you to dial in as much of the dry signal as you want. If you want a wet-only signal, very cheap modification is to simply run this run this pot all the way to ground, and your dry signal will go away on your output. There's a 100K resistor here in parallel with an 820 picofarad capacitor. This is a jack. This is your first foot switch, and this will remove the dry signal. It will bypass the Echorec, the echo circuitry. And then from this 100K resistor, we come to this potentiometer here. It's a half mega ohm, 500K. This is on your front panel the input level or record level pot, which is then coupled here through a 220K resistor in parallel with 220 picofarad to this next amplification stage. This signal coming in from here, this is your feedback or your number of repetitions, your swell length. We'll talk about that a little bit later. We'll just concentrate right now on the dry signal. Feeds this triode, which is now operated with a 1 kilo ohm resistor on the cathode. There is no bypass capacitor here, so it kind of keeps the gain down a little bit. 100K plate resistor and a 0.0022 microfarad capacitor coupling to the next stage, which is your record amplifier. So your signal comes through here, through this triode, and the signal goes to two places. One, through here, this 200K resistor. It's coupled through another 27K resistor. This symbol here annotates the record head. So here's your path through this triode over here to the record head. Also, there's a potentiometer in the back of the unit which sets the sensitivity to your EM81 Magic Eye tube. Now you'll notice on the Binson Babies that the EM81 does not have razor sharp edges on the on the Magic Eye. As those two clamshells come together, you'll notice they're blurry, and that's because they do not rectify this signal, and there's an AC on this grid. You'll notice on the Echorec 2s there'll be a reverse bias diode here, which then puts DC on this grid, which then allows you to have a really nice sharp edge. Okay. All right, so that your signal is then put onto this record head. This device out here is an oscillator, is the bias oscillator for the record process. I'm not going to get into how that works. Suffice to say that without this, your quality of your recording is going to be horrible and basically unusable. This oscillator operates at a frequency of 50 kilohertz, which is set with this capacitor. And there is a coil out here. The impedance of this capacitance in parallel with this inductance will set your frequency. You will notice on almost all of the Echorecs that this capacitor will be a precision Mylar capacitor, and that is an attempt to keep the bias signal constant, if you will, constant frequency. And is that important or not? That can be debated, considering you're not making a recording that you will play back on multiple playback decks. This is a one and done type system. Not a bad idea. But anyway, this then creates a 50 kilohertz sine wave, which is coupled through this 0.01 microfarad capacitor. And then there is a mica variable capacitor, about 150 picofarads, located in various locations. You can't miss these things. They look like wafers with a screw head in them. And basically that sets the amplitude of your bias signal. The specification is for 0.9 milliamps at 50 kilohertz. Very hard to read that, very hard to set that. So basically what I will tend to do is put an oscilloscope across the record head, and believe it or not, that signal generates up to a 300 volt peak to peak 50 kilohertz sine wave across the record head. When I first saw that, I thought it was wrong, but if you go through and do the calculations based on the impedance of the record heads and so forth, that's about right. Basically, you want to set that such that you have good quality sound on your recordings. You can do that. I generally set it, make sure it's over about 120 volts, and that tends to be fine. Remember, this is not a super high fidelity recording system. If you get 7, 8, 9, maybe 10 kilohertz out of it, you're lucky. But fundamentally, what you want to do is make sure that this is set such that when you put a sine wave in here, you get a nice sine wave out. So let's talk about the output. So come down here to this triode. This A basically goes off to the playback heads. Well, actually it goes to the selector switch, which interestingly is not shown here. On the babies and on the Echorec ones, there is not any sort of buffer amplification off of the playback heads. The playback heads are wired directly to the switch, and the output of the switch comes here to this A point in the schematic picture here. So it's a direct connection to one or more heads through that selector switch. Those are coupled to this triode through a couple of low voltage ceramic capacitors, 220 picofarads and a 0.0022 microfarad capacitor. These are low voltage ceramic types, and I have seen these fail. And the general symptom of that is crackling on a given record head, or in this case, it would be universal. On the Echorec 2s, where there's buffer amplifiers, there's one of these across each and every head, and each, into this triode here. On the Echorec 2s, there will be 4 of these circuits prior to the switch, but we don't have that here, so let's not confuse the issue. This drives a grounded cathode triode 47K plate resistor through a 10K 0.01 microfarad capacitor. Here is your second foot switch jack. This will kill the echoes 100% of the time. So you can still have wet signal, but then this will shut the echoes off. All right, so we come out of here through a 100K resistor, which is now driving this triode. This particular triode, there's a universal tone control. And this is true on both this and the Echorec 2. The Echorec 2 actually has individual tone controls on every head. However, in this case, it's just your singular tone control. This 20K pot is on the front panel, and this is your tone. Okay. 1 mega ohm grounding resistor here. This triode runs with a 1.5K cathode resistor, 40.047 microfarad bypass. That then goes through this 0.022 microfarad capacitor, and our signal goes a bunch of places from here. So as we come right off of here, the first place that you'll notice is there will be a potentiometer. This is a trim pot on the back, and this sets the basic front end gain of your level of repeats. All right. This 200K ohm pot is your front panel length of swell. So what you do here is you'll set this to the dial indication wherever you want it, where you want oscillation to start, and then you'll adjust this trim pot to make that happen. It's a kind of an iterative process. But that feedback circuit has 2 pots to it. One is front panel easily accessible. This other one here is on the back of the unit, and that sets your essentially your gain floor. All right. So coming through this 470K resistor from here, we then hit this pot, this 500K ohm pot, and then that is your wet signal, which is mixed with your dry signal with this resistor network, and out you go. So that is your basic operation of your Binson Echorec. So if there are any questions or whatever, post them in the comments. I'll go through the Echorec 2 at another time. So I hope this was useful to you, and thank you very much.